So to start unit 4, we're moving right along here. We're going to review parts of a circle here today. At least a few important parts of a circle for this next unit. First, most important part of a circle, defines a circle, is the radius. There are some other parts that we've talked about. Tangent, all points but one are outside the circle. So the line that's outside the circle, or a line segment that's outside the circle, just touches it, but it never goes inside of the circle. Secant, line that contains points both inside and outside of a circle. Now these next two are ones that we have not seen before. First one is called a reference diameter. It is typically horizontal, sometimes vertical. Technically, it can be any diameter that is specified as a reference diameter. But for most purposes, the standard reference diameter is the horizontal diameter of the circle. It is the diameter that is used to reference other locations on the circle. For example, we talk about angles and stuff like that. If I call this point of the circle 0 degrees, they move around the circle, the other angles are from that point. So the reference diameter, one end of the reference diameter has to start at 0 degrees, so the other angles are oriented off that reference diameter. So like if this is a 40-degree location, the radius from the center of the circle to that 40-degree location forms a 40-degree angle with the reference diameter. This next one is very important. It's one that we don't see much anymore. It used to be very common. Point on the circle has this property. Every point on the circle has this property. Distance from that point to the reference diameter. Now remember, distance from a point to a line is measured at a perpendicular. That distance is called the sine of that point. Every point on this circle has a different sine. This point here has a little bit larger sine than the one we defined there. This point down here, significantly smaller sine. Every point on the circle has its own sine. Now, there will be 4 points on the circle that have the same sine as this point. Because, well, right here, this point here is the exact same distance as this one is. This point down here would be the exact same distance away. This point here would be the same distance away. That's important to note that there are 4 points on the circle that have the same sine. 2 of them above the reference diameter, 2 of them below the reference diameter, but for every sine, every length of sine, there are 4 points that have that length. Why am I talking about all this crap? We're going to define something called a unit circle with radius 1 unit. That means from the center of the circle out, this is 1 unit. Circumference of that unit circle, pi. If the radius is 1, that means the diameter is 2, and the circumference is pi times diameter. Area, pi. 1 pi times radius squared, well, radius of 1. 1 squared is just 1, so it's just pi times 1 or pi. This unit circle is very important to us. First of all, we're going to define that reference diameter to be that horizontal diameter. So this would be 0 degrees, and we go around. Now we're going to put in a secondary reference diameter going vertically, just so we get that kind of that crosshair effect that we do from our standard XY graph. So that's 90 degrees up top, 180 degrees over here, 270 degrees down here. So just like we showed above, an angle is defined technically off of its point around the arc of the circle. Let's say that from here to here, that is a 25-degree arc. That means that this angle in here has to be a 25-degree angle. And those crosshairs are in the middle of that. That's a little bit better. Of course, this is 0-degree point is often referred to as the initial side. This length from here to here referred to as the initial side. When we're creating angles. Called the initial side for obvious reasons. That's where 0 degrees is, so that's where our rotation would start. Let's say we rotate an angle, and I'm going to call that angle theta. That symbol theta just means any unknown angle. This here is the terminal side. That's where the rotation stops. If we're rotating from 0 to whatever the size of that angle is, that's where it stops. Now remember, we said technically the angle was really this arc on the outside of the circle. That's theta degrees. So that point on the arc of the circle defines a lot of things. Now remember, we said every point has a value referred to as a sine. So the sine of that angle theta is whatever that distance is. That distance is consistent because this is a unit circle, which means the radius is 1. That distance will always be the same for that angle theta. If I extend the radius here out a ways, and I draw a tangent. The tangent is the tangent for our functions here is always tangent at the reference diameter. So this is the end of the reference diameter. The tangent has to be tangent there. I extend that up. I make this bigger triangle. So now you'll see I've made 2 right triangles here. One is the small one with the sine on it. The other one is this one. Remember, because the radius is perpendicular to tangent. This length from the center of the unit circle along the radius and extending through the edge of the circle out to where it intersects that tangent. Remember, a line that contains points both inside and outside of a circle is called that is the secant of angle theta. And of course, the distance from where that intersects the tangent back to the reference diameter or the 0 degree point, that is the tangent. Okay. Nothing worse than getting it right. Or I sneezed in it the other day. Oof. So anyway, these are the three main trig functions right here. Sine, tangent, and secant. We might be asking, where's cosine? We will learn sine, tangent, and cosine, not secant. Well, there is a strong relationship between secant and cosine that we'll see in a few minutes. But technically, secant is the third main trig function. Cosine is what we refer to as a cofunction. Cofunction means of the complement. What does that mean? Of the complement. So, I ask you for the cosine of something. This is asking me for the sine of the complement of whatever angle it is that we're looking at. This is our reference diameter here. Horizontal diameter. This complementary reference diameter. What on earth does that mean? Well, horizontal and vertical are always perpendicular. In other words, they're always at a right angle. That means this angle here is a right angle. So the complement of angle theta, this angle right here, that's the complement of theta. So all it does is I'm looking at that terminal side, this terminal side here, and I'm looking at the other side of it instead of looking at this bottom side between the terminal side and the horizontal diameter. Complement means I'm looking at the top side between the terminal side and that vertical or complementary reference diameter. So from that point to there, that is the cosine of the angle. I'm going to redraw this just to make it a little easier to see. We circled out an egg. That's round. Here's our terminal side here. This is angle theta. So yes, this distance here is the cosine of theta. So the vertical reference diameter, the complementary diameter, instead of the normal reference diameter. Now I extend this out. The tangent has to be tangent at the reference diameter, so that would be back here. This up here is referred to as the cotangent of theta. In other words, it's the tangent of that complementary angle. This right here is going to be the complement theta. And of course, this length here all this stuff is about circles. How on earth did it become applied triangles? Well, there's a couple of factors involved. The first one, if you have to remember back about 2 weeks ago, we said that every right triangle has the same angle. I'll call this angle alpha here. No matter how big that angle is, if it has the angle alpha and it's a right triangle, we know those triangles are similar because we have the right angle, we have angle alpha. If we have 2 out of the 3 angles, the third one has to be the same. So those have to be similar triangles. So that all right triangles, that if we have one of the other angles the same, they are similar triangles. So I come back up here to these triangles here. There's 2 main triangles formed with our main trig function. One is this one right here. Take a look at that triangle here for a second. This side right here, the hypotenuse, the radius of the circle. It has a length of 1 unit. Of course, this is angle theta. This side right here was the sine of angle theta. This side down here, this whole side, we said was the sine of, or the cosine of theta, right? This up here really is the cosine of theta, but that's the same length as this piece down here. Cosine of theta. If I draw any triangle, right triangle where this angle is theta, now I'm going to label the sides of this triangle with some special names. Of course, this is the hypotenuse. We learned that back when we did a squared plus b squared equals c squared. The other 2 sides, of course, are legs. But now we're going to have special names for them. The leg that touches the angle that we're looking at. That would be this leg down here. Adjacent means next to or touching. That leg touches our angle. The leg that is opposite or across from our angle is going to be the opposite leg. You might be seeing some relationships here already, but let's take it even further. Now let's look at this big triangle out here. This angle is still theta, only now it's this bottom side that is 1 unit, because that's the radius of the circle here. The hypotenuse here was the secant of, and this side over here was the tangent of theta. Where did my trig functions come from? Really simple. Let's look at sine first. I'm going to compare it to the 1 that's its hypotenuse. So it's sine over 1. Going over to this triangle here, where I have my sides labeled, which side of that highlighted triangle corresponds to the sine of our first triangle? Sine, it would be the and which side of the highlighted triangle corresponds to the one of the original triangle? Hypotenuse. Sine of an angle is equal to the opposite side of the triangle divided by the hypotenuse. Whatever the lengths of those sides are, that ratio will be the same for every triangle, every right triangle that has that angle of theta, whatever theta is. Well, let's look at cosine here. I'm going to compare cosine also back to the 1. Going to the highlighted triangle. Which side of that highlighted triangle corresponds to the cosine? The course corresponding to the 1 is still the cosine of an angle is equal to the length of the adjacent side divided by the length of the hypotenuse. To the tangent of an angle, we're going over here now. We're going to compare the tangent to the side that's 1. Now in our highlighted triangle, what side of that triangle corresponds to the tangent? The opposite side. I'm just going to go OPP for opposite. Which side corresponds to the 1? I've heard that song a long time. The adjacent side. You go ADJ for adjacent. So the tangent of an angle is the length of the opposite side divided by the length of the adjacent side. And finally, let's do secant of an angle. Can't compare to 1. So which side of the highlighted triangle corresponds to the secant?
Hypotenuse.
Hypotenuse. And of course, still corresponding to the 1 is the adjacent. I could pull a third triangle in here. It would be this triangle here, my cotangent and my co. This angle up here is actually still theta, isn't it? Because it's the complement of this angle down here. This is the complementary angle down here. Right triangle. The two non-right angles of a right triangle have to be complements because they add up to 180 and we have a 90-degree angle there. So this is the cosecant. Tangent. Of course, this side is the radius. That side is 1. This is a little tougher to visualize. If I compare the cotangent of theta to 1. Cotangent is actually the adjacent side. 1 is actually the opposite side. I got cosecant of 1. Well, cosecant is the hypotenuse, and 1 is still the opposite side. What I have up here, these 6 trig functions should be written down somewhere in your notes where you can get at them pretty quickly. I'd recommend like recopy them in the back page of your notebook or something because you're going to be referring back to them often. And I'm going to point out some things now that, well, make it pretty handy. Let's look at this secant. We said secant is actually our third major trig function. But on your calculator, they use cosine, not secant. Well, let's look at cosine and secant. Cosine, I don't need to have it over 1. I can get rid of that over 1. Cosine is the adjacent side, hypotenuse. Secant of that angle is the hypotenuse over side. Do we see a relationship there? Those are reciprocals, right? Tangent of an angle, reciprocal, the cosine of that angle. If we're going to calculate on a calculator, that's exactly how we would calculate it. Same is true for the cotangent. Cotangent of an angle is adjacent over opposite. Tangent of an angle, opposite over adjacent. The reciprocals, the cotangent, 1 divided by the tangent of that reciprocal of the tangent. Let's see what's coming up next. Sine of an angle, opposite over hypotenuse. The cosecant of an angle, hypotenuse over opposite. Cosecant, sine. So, big warning here. Tangent and cotangent pair is pretty easy to remember. It makes sense. The tangent and the cotangent go together. However, a lot of mistakes made. Cosine does not go with cosecant, it goes with the secant. And sine goes with the cosecant. So be careful, that is easy to mix up. Let's look at a right triangle. And let's say it has lengths of, what do I want to put in here? 12, 16, and 20. Whatever units you want to put. Inches, feet, centimeters, whatever. When we put them in our ratio, they're going to cancel out anyway. Sine of angle A. Remember, sine is opposite over hypotenuse, right? Well, for angle A, which side is the opposite? 12 is the opposite. Which side is the hypotenuse? 20 would be the hypotenuse. Sine of angle A would be 12 over 20, or 0.6. Cosine is adjacent over hypotenuse. What is the cosine, the adjacent side for angle A? 16, that's the adjacent side. 16 over 20. 0.8 is the cosine. Tangent next. Tangent of A is the opposite adjacent. Here, what would be the opposite side? 12 and adjacent. 12 over 16, or 0.75. Well, let's throw a screwball into this. What's the sine of angle B? Well, here's angle B. Sine is opposite over hypotenuse, but to angle B, which side is the opposite? Is the opposite. 20 is still the hypotenuse. That does not change. 16 over 20, or 0.8. The hypotenuse is always the hypotenuse, no matter what angle we're looking at. But the opposite side and the adjacent side switch places depending on which angle we're focusing on. If I want to do the cosine of B, adjacent side would be 12. Good. Over the hypotenuse. 6. Notice sine of A, cosine of B are the same. Why? Well, because those two angles are complements. Cosine of B is saying, what's the sine of the complement? Complement of B is A, so the cosine of B is equal to the sine of A. Tangent of B, or not cotangent, tangent of B. Opposite over adjacent, which will be, in this case, 12, 1.333. Typically, we round trig functions to 4 places. So there's a whole number there that's 1.333. If it was 0, it'd be 4 decimal places. Well, let's let the fun continue. Secant of angle A. Now remember, secant is hypotenuse over adjacent. Circle of the cosine. Hypotenuse, according to angle A, of course, the hypotenuse is always 20 in this triangle. What's the adjacent side according to angle A? 5. Note that if I took 1 divided by the cosine of A, that'd be 1 divided by 0.8, which is also 1.25. So on my calculator, there is no secant button. But I'll be able to calculate it using cosine. Now what my calculator does is rather than giving you a triangle like this and using the ratio of the sides to find the value of the function, the calculator uses the angle to find it. So if I want to know sine of 30 degrees. On our calculator, I've got sine right there. Most of your calculators just type in sine, then 30 and hit equals. I got a strange answer there. A negative 0.98888. Negative 0.98803, whatever. There's a reason my answer is strange. That is not the correct answer. The reason it's strange is if you go into your mode, you'll see that I am set into radian mode. My angle was given in degrees. So you have to change, make sure your mode is set to degrees. 0.5 is the correct answer. So now that I'm set to degrees, I go sine of 30, and I do get 0.5. Cosine of 30 degrees should be 0.866. Tangent of 30. 577. Let's go for the fun ones. Yeah, to 30 degrees. Can't make it easy. Remember we said the secant goes after the cosine. So most of your calculators have a key that looks like this, x to the negative 1. That is the reciprocal key. Here's what you're going to do. You're going to do sine. Remember, secant goes with, not sine, but with cosine, right? You go cosine of 30, you're going to hit equals, and use that x negative 1 key. Cosine of 30, 0.866. I do the x negative 1 key, gives me 1.155. That is the secant of 30 degrees. The other way you could do it is if use a cosine of 30. I believe it works if you just put it outside the parentheses. Cosine of 30, close your parentheses and hit the x negative 1 before you hit the cosecant of 30. What function goes with cosecant? Sine 30 And again, outside the parentheses, before you hit equals, hit the x negative 1. That's 2. Makes sense? 0.5, 1 divided by 0.5 is 2. Reciprocal of 1/2 is 2. So tangent to 30, what trig function are we going to use? There you go. Tangent to 30, close that parentheses, and x negative 1 before we hit equals. Gives us 1.732. So that is where our trig functions all come from. And an introduction to the basic calculations on the calculator. We will look at them more tomorrow. I'm going to have to upload a new packet here in the Blackboard. Those of you in the room, I think I've got enough copies. Page 38 through 341. I'm going to do the 1s, 5s, and 9s rather than all the odds. So rather than doing 1, 3, 5, 7, 9, 11, 13, 15, just do 1, 5, 9, 11, 15, 19. Just because there's a lot of problems there. I just don't want you to go home and do 27 problems. And I have to back off at some point. So we've got about 6 minutes left here. For those of you in the room, I'll grab the packet for you.